In this section, our objective is to be able to solve a system of inequalities in two variables graphically. Let's look at situation number 1. During the summer, you want to earn at least $200 per week. You earn $10 per hour working as a lifeguard, and you earn $8 per hour working at the grocery store. You can work at most 30 hours per week. Remember, these words mean greater than or equal to, or less than or equal to, which means we would be writing inequalities, two of them making a system of inequalities. So before we continue to solve this situation, let's take a look at how to solve systems of inequalities. Examples: graph the system of inequalities. Let's take a look at this first one. Notice it's already in slope-intercept form, y equals mx plus b. The b in this inequality is 2, so we'll go up to 2 on the y-axis for the y-intercept. B is where we begin. M is how we move. M is the slope. M is 1/2. So from here we move up 1 and then over 2. Up 1, over 2. We run out of room, so we go backwards. Down 1, backwards 2. Down 1, backwards 2. Notice that this is just less than, not less than or equal to. So when we connect our points using our straight edge, we'll connect with a dashed line, meaning that all the solutions go up to this line but are not equal to the points on that line. Then, because this says less than, that means to shade down. So for shading down, putting my pencil on the line somewhere, I know I have to go down. Now, very, very lightly, we're going to shade on this side of the line, very lightly. Let's do the other inequality. This one is also in slope-intercept form. We begin with 5. 1, 2, 3, 4, 5. We move -2. -2 is the slope. So from this point, down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1. Keep going until we run out of room. Go backwards if we need to. Now this one says greater than or equal to. So when it's equal, I make a solid line using my straight edge to connect the points. Now because this says greater than or equal to, that means shade above the line. Y goes up and down, so Y is greater than means Y goes up. So putting my pencil somewhere on the line and shading up means I have to shade on this side of the green line. So very, very lightly, we see we have to shade here. Now the solution to the system of equations is the region where both shadings occurred. There's only blue here, there's only green here, but this one has blue and green. So this is the region where now we get out our pencil and we really shade darkly over here. We don't need or don't want the points that occur anywhere else. So we can take our eraser and we can erase here and erase here. And this region consists of all of the solutions to this system of inequalities. Which of the following points are solutions to the system of inequalities? Circle them and plot them in the graph. 4, 1. Let's see where that is. 1, 2, 3, 4, 1. Notice that that's in the shaded region. Therefore, this is a solution to the system of inequalities. What about -1, 0? Where's -1, 0? Right here. Is that in the shaded region? where both inequalities have shaded? No, it's not. So that one is not a solution. What about 2, 1? X is 2, y is 1. That point is right here. Well, the shaded region includes any of its borders that is a solid line. So this point is a solution to this system. What about 0, 5? Notice that 0, 5 is also on this solid line, but is it bordering this region right here that is the area of solutions? No, it's not. It's outside of that region. So this one is also not a solution. How about 4, 4? 1, 2, 3, 4. 1, 2, 3, 4. Again, this point is on the line. It's bordering the shaded region, but notice it's on the dashed line. It won't make that first inequality true, so it is not a solution as well. Remember, another way that we can tell, besides looking at the graph, is by plugging them in to the system of inequalities. Let's just prove it with 4, 4. The x is 4 and the y is 4. So for y is less than 1/2 x plus 2, 4 is less than 1/2 times 4 plus 2. 1/2 of 4 is 2. 2 plus 2 is 4. Is 4 less than 4? No, that's not true. So it's not a solution. Whereas the ones we circled would make both of these inequalities true. Let's take a look at number 2. X is less than 3. This only has an x in it, so we think of vux. Vux when it only has an x, and vux means vertical. Vertical means up and down. So we go find 3 on the x-axis. And because this is less than or equal to, we're only drawing a dashed line that goes through 3 on the x-axis. So dashed line down, dashed line up, and there is our vertical line. Where do we shade? Well, this time it's x is less than. X goes right and left in the x direction. So where are numbers that are less than 3? 2, 1, 0, negatives, everything to the left. So very lightly, we'll shade on this side of the line. X, left or right. Now let's take a look at this equation, which is in inequality. It's in standard form. Remember, ax plus by equals c is standard form. We graph this using intercepts. So covering up the y, 2x equals 2, dividing by 2, x equals 1. So the x-intercept 1. And then covering up the other one, y equals 2. Nothing to solve for there, so let's go graph 2 on the y-intercept. Now, we can get our straightedge and connect the points, but I'd like to make sure that this is really straight. So let's see from this point to this point how we move. Down 2 over 1. So let's continue that pattern. Down 2 over 1. Down 2 over 1, or backwards. Now we can get our straightedge and connect the points. This has an equals, so we will connect it with a solid line. Of course, we're always using our straight edge. Because this is y is greater than, and it's positive y, that means we're going to shade above the line. So putting our pencil on the line, we're going up. So we're going to very lightly shade on this side of the line. Now eventually, you'll get used to seeing where the shaded region intersects without having to do all of the shading that eventually will have to be erased. Let's see where both shadings occur. This is only blue, so not here. This is only green, so not here. This is blue and green in this region. So I'm going to shade very darkly in this region here. And then I'm going to get my eraser and erase the other regions that are not part of that intersection. Which of the following points are solutions to the system of inequalities? Circle them and plot them in the graph. 2, 2, 2, 2. That's in the shaded region, so that is a solution to the system of inequalities. 0, 2, 0, 2. It's on a solid line that's bordering that region, so that's also a solution to the system of inequalities. 3, 0 is bordering this region that's shaded, but it's on a dashed line, and on a dashed line, it's not a solution. 3, negative 4, 1, 2, 3, 1, 2, 3, 4 is on an intersection point of two lines that border this region. But again, if it's on a dashed line, that means it's not a solution. And finally, 4, 1, 1, 2, 3, 4, 1, outside of the shaded region, not a solution. Now, this is also a good way to tell that you've shaded in the correct spot. Pick a point that works in both of the inequalities, or pick a point in your shaded region, such as 2, 2, and plug it in to both of the inequalities. So x is less than 3, we can write, instead of x, 2 is less than 3. That's a true statement. So we check the other one. Instead of 2x, 2 times 2. Instead of y, the y is 2, greater than or equal to 2. 2 times 2 is 4, and 4 plus 2 is 6. Is 6 greater than or equal to 2? Yes, it is. So picking a point in the region that we think is supposed to be shaded and plugging it in will show us that we've shaded in the correct place. Now we're able to revisit situation number 1. During the summer, you want to earn at least $200 per week. So that's greater than or equal to 200. You earn $10 per hour working as a lifeguard and $8 per hour working at the grocery store. You can work at most 30 hours per week. At most is less than or equal to 30. So notice that we're talking about the amount of hours that we can work, and there's two types of jobs that we're working. So let's call X the number of hours working as a lifeguard, and let's call Y the number of hours working at the grocery store. Now, there's the amount of money that we can earn for each. So $10 per hour for the lifeguard. So there's 10x. And $8 per hour for the grocery store. So add to that 8 times the y variable. If this is the money and this is the money, we want to put that together with the money. So at least greater than or equal to 200. Now we have the amount of hours, at most 30 hours. There's x as a number of hours, and there's y as a number of hours. So x plus y is at most less than or equal to 30. So the first thing we're going to do to try to solve this system of inequalities is graph the system to determine the possible solutions. Notice that both of these are in standard form, so let's take it like that. 10x plus 8y greater than or equal to 200. Using the cover-up method, 10x, forget about the y, equals 200, so x equals 20. And take the y term, positive 8y, equals 200, so y is 25. Now notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I can't get up to x is 20. So sometimes we have to label our graph differently. Let's count by fives. 5, 10, 15, 20, 25, 30, so on and so forth. And if we're going to do that on the x-axis, let's also do that on the y-axis. 5, 10, 15, 20, 25, 30, and so on. Now we can plot the x-intercept 20 and the y-intercept 25. This is an greater than or equal, so that means we'll connect these points with a solid line. And we'll shade for y is greater than, positive y is greater than, up. So from this line, we're going to shade above it, but just lightly. Let's take a look at the other one. X plus y less than or equal to 30. Using the cover-up method or the intercepts, just x equals 30, and then just positive y equals 30. So the x-intercept is 30, and the y-intercept is 30. This has also an equals, less than or equal, so we'll connect these points with a solid line as well. Using our straight edge, and then this one is less than, so that means shade down. So everything below this line, just lightly. Now where is both regions shaded? Well, this is only blue, this is only green, and it's tough to see, but we've got blue and green right between these lines. So this is the region that we're going to shade. Now notice that we've only given you the positive x coordinates and the positive y coordinates because we're not going to be able to work a negative number of hours. That just doesn't make sense. So this region in here gives us all of the possible combinations that can work for how many hours we can work. B, if you work 5 hours per week as a lifeguard, remember lifeguard is the x, so x is 5, and 15 hours per week at the grocery store, so that means the y is 15, will you earn at least $200 per week? Well, let's go back to our system of equations. 10x plus 8y is greater than or equal to 200. Can we make it? Well, let's try to plug it in. 5 in for x and 15 in for y. Now before we even do that, going back to our graph, x is 5 and y is 15, that point is not in our shaded region. So we should see that this doesn't work. 10 times 5 is 50, and 8 times 15 is 90, and 50 plus 90 is 140. Is 140 greater than 200? No, this is not a true statement. So can we work that amount of hours to earn what we want? No, we can't. C, you are scheduled to work 20 hours per week at the grocery store. Now remember that the grocery store is the y variable. How many hours we work at the grocery store is y. So they're giving us that y is 20. What is the range of hours you can work as a lifeguard? So remember the lifeguard, that's the x. So they're asking what can x be to earn at least $200 per week. So remember that first inequality, 10x plus 8y has to be greater than or equal to 200. So similar to how we did part B, let's take that y as 20 and put it in here. So 10x plus 8 times 20, or 160, has to be greater than or equal to 200. Subtract 160 from both sides. 10x has to be greater than or equal to 40. And then divide both sides by 10. X has to be greater than or equal to 4. But there's another inequality that we have to consider. And that's the inequality that x plus y has to be less than or equal to 30. So let's take the y, being 20, and plug it in here. So x plus 20 has to be less than or equal to 30. Subtract 20 from both sides, x has to be less than or equal to 10. So put these two things together. X has to be greater than or equal to 4, but less than or equal to 10. So if x is the number of hours working as a lifeguard, we can work anywhere from 4 hours to 10 hours as a lifeguard. So that's how we'll have to answer this question. From 4 hours to 10 hours. Those are all the possible solutions. We could work 5 hours, that would work. If we wanted to work the minimum possible, 4 hours would work. If we wanted to work as much as possible, only 10 hours, or at most 10 hours, and anything in between. See how a system of inequalities can be useful? Now take a couple of minutes to write a summary explaining how to know where to find the solutions for a system of inequalities. See you in class.